Hello guys, welcome to Tony Tech Pro. In this video I'm going to show you, or I'm going to do some tutorial on how to do the calculation of this Ferrite Core transformer. Some people call it a choke transformer, while some call it Ferrite Core transformer. So before we dive into how to do the calculation, I need to explain the reason why some prefer this Ferrite Core transformer. Normally, we know that this Ferrite Core transformer is using high frequency power supply. So the reason for that is because it is very compatible in circuits more than the normal power transformer. And another reason why we use this Ferrite Core transformer is because of it has high permeability. What I mean by that is this material here has high permeability more than the normal power transformer, and the normal power transformer is normally using low frequency. That's why it has a much turn. But with this Ferrite Core transformer, that works in high frequency, because the higher the frequency, the lower the turns, and it also has some features of reducing the eddy current and the switching losses. So that is the little I can say about this Ferrite Core transformer. So in order to use this in order to use it, or in order to rewind your own Ferrite Core transformer, there is some things that we have to take in place, as in the formula to do the formula for the calculation of the winding. So before we go into that, we have to take some parameters into hand. First of all, we have to know our input voltage, which is the primary volt. We say V in equals to, can be 12 volts, it can be 12 volts, it can be 24 volt, 48 volt, depending on the voltage you want to apply at the primary. So for this example, we are going to use 12 volts. And another thing is the frequency, which is F. Normally this Ferrite Core transformer in switch mode power supply, their frequency is normally from 50 kilohertz to 35 kilohertz, depending on what you are using it for. But for this example, I'm going to use a 50 kilohertz frequency. Then the B mass, which is the permeability, normally is from 1000 to 2000, but for this example I'm going to use 15. So this is what you are going to make use of. Then another thing is the area, which is normally AC or AE. It's a cross-sectional area of this Ferrite Core transformer. So this formula here for calculating the primary turns, the formula is equals to V in times 10 raised to the power 8 divided by 4 times F times P mass times AC. This is the formula for calculating the primary turns. Why this one is the parameter we need to take in hand, as in the desired things that we want from this Ferrite Core. We are going to apply the V in is 12 volts, our switching frequency is 50 kilohertz. The permeability we are going to use is going to be 15. The area core, we have to measure the area core of this Ferrite Core. So for that, before I go into how to solve all these things, first I will show you how to dismantle this already made Ferrite Core transformer, so that we can take the cross-sectional area measurement of this. So before we dismantle this, you have to cook it you have to boil it up to 30 minutes so that it will be easier for us to dismantle. So I'm going to do that, then I'll come back to show you how to dismantle this. All you have to do is to put it in a bucket or in a bowl, pour water and boil it for 30 minutes. So I'm going to do that, then I'll come back to show you how to dismantle this Ferrite Core transformer. So for our calculation, the area and the cross-sectional area must be in square meter. So for that we have the cross-sectional area of this Ferrite Core transformer is equals to 2 square centimeter square. So let's plug in our values. So we have 2 tons in the primary. So for the secondary, all we have to do is to find the turn ratio of the secondary and the primary. To find the wire gauge of this winding, first of all, this Ferrite Core transformer is 2000 watts. Ferrite Core for the power rating is 2000 watts. So 2000 watts divided by the primary input voltage is 12 volts will give us the current that will pass through the primary. Then for the secondary, we want to obtain a 310 volts at the secondary. So divided by 2000 watts will also give us the current that will pass through the secondary. So I'll plug in the values, then we'll go ahead to make the rewind the Ferrite Core. So this is the final look. I'll be showing you how this Ferrite Core transformer will perform in my next video, when I'm going to use it to build an inverter circuit, transformerless inverter circuit, or chopper inverter, as so many of you might call it. So thank you for watching, and please make sure you subscribe to this channel and press the bell icon so that you get notified whenever we upload new awesome videos. Thank you, and see you next time.